Alright, so now I'm working on the second take-home Unit 1 exemplar for modern physics. This one, the scenario is that when a sodium metal is illuminated with light of wavelength 4.2 times 10 to the negative 7 meters, the stopping potential is found to be 0.65 volts. It's lambda 1 and V1. When the wavelength is changed to 3.1 times 10 to the negative 7 meters, and the stopping voltage potential is 1.7 volts. Using only this data, find the value for Planck's constant times the speed of light, hc, and then determine the work function for sodium. So to start, we want to use the photoelectric equation found by Einstein, where EV equals hc over lambda minus phi, where E is the charge of an electron, V is the stopping potential, H is Planck's constant, C is the speed of light, lambda is the wavelength of the light, and phi is the work function. So we don't know phi, but we know everything else. So this means we can set it as two equations, EV1 and EV2. With the two wavelengths and the two voltages. So since we don't know phi, we can subtract these two equations from each other to cancel it out. And this allows us to use variables that we actually know. So we want to go EV1, we want EV2 minus EV1 is equal to hc over lambda 2 minus hc over lambda 1. So hc is the same essentially, so we can rearrange to find hc using these other variables. We have hc equals e to the v2 minus v1, just merging these together, over 1 over lambda 2 minus 1 over lambda 1 Now when we plug in our values of E and our V2 and our V1 and our lambda 2 and lambda 1, we get that HC is equal to 1.988 times 10 to the negative 25 J times N. And now that we know this value of HC, we can plug it back into our original photoelectric equation. So we have EV, we're going to use the voltage and the wavelength from the first set of light, equals HC lambda 1 minus phi. When we rearrange for phi, since that's what we want to solve, we get HC over lambda 1 minus EV1. When we plug in all our known variables again, we get that it's approximately 3.7 times 10 to the negative 19 joules. Now I looked up the work function for sodium, and it was 4.4 times 10 to the negative 19 joules. And I believe that this difference is just from potential rounding errors. But all the math should be correct. It's just math rounding. And so yes, that is our work function for sodium.